Hello again, this is section 4.3, day 2, and in this lesson we'll be working on graphs for tangent and cotangent functions. So far we learned how to graph sine, cosine, then graph the secant and cosecant. Today we'll learn about tangent and cotangent. Okay, so to be able to graph, we will need to have the equation for the tangent. We'll look at tangent first. So the equation for tangent function is y equals c plus a tangent b x minus d. So this is about the same as what we had earlier in the first and second sections with sine, cosine, with shifts and amplitude, everything. Okay, to be able to graph tangent, let's look at the unit circle. So as you know, tangent is sine over cosine. So looking at the unit circle, we get the tangent function by dividing the y value by the x value, right? So, and again, from the unit circle, looking closely at the values of x and y and the values of tangent, you will see that the tangent function will repeat itself. So the tangent will be from negative pi over 2, which it is the same as 3 pi over 2, all the way to pi over 2. After that period, it will start repeating itself. So let's start graphing. Let's have the x and y here, and we will see a graph of tangent. So as you remember, on the x-axis we will label the values of the angles, right? And the value of the tangent or any trig function will be on the y-axis. Okay, so we said for tangent, we will start from negative pi over 2. So that's here. And it's a negative pi over 2. All the way to pi over 2. So this is one period for a tangent function, okay? After that, the tangent graph will repeat itself. Okay, let's look at some values for the x here in between the negative pi over 2 and pi over 2. First one we will take is the negative pi over 4 and 0, and then pi over 4. Okay? So looking at the unit circle for each point, when the angle is negative pi over 2, you will see that point is 0, negative 1. So dividing the y value by the x value, that's negative 1, divided by 0, that is undefined, right? We can't divide by 0. So when it is undefined, I am going to graph a vertical line like this, and I will say that is the vertical asymptote for the tangent. So the tangent function will never touches this vertical line, the vertical asymptotes. Okay, next let's look at when the x is negative pi over 4, and looking at the unit circle again, you will see that is negative root 2 over 2 divided by root 2 over 2, and that will give me negative 1. Okay? Here it is. The point is right here. Okay? Negative pi over 4, negative 1. When x or the angle is 0, the point is 1, 0. dividing the y by the x value, that will give me a 0. 0 divided by 1 is 0. Next, when x is pi over 4, the point is root 2 over 2, and the y value is root 2 over 2. Divide the y by the x value, that will give you 1. So here is my next point. Okay. Next, when the x value or the angle is pi over 2, looking at the point in the unit circle, you will see it's 0, 1. So you will be dividing, again, 1 divided by 0, and that is undefined. Again, I'm going to do this vertical line, and we'll say that this is the vertical asymptote, right? So now I'm ready to graph the tangent function, and the tangent graph will look like this. Okay? As you see, it goes from negative infinity here and up to positive infinity. Okay, so we will say that the graph goes through the origin, 0, 0. Okay. The graph goes or if we have shift, like vertical or horizontal shift, it will go through that new origin, the shifted one. And it extends one step, as you see, one step each way. One step each way of the origin. Okay. This graph, when we have A is positive, if A is positive, the graph will look like this, the amplitude. If A is positive. Okay, let's look at the graph when A is negative. It won't be the same, but it will be reflected. Let's do this here. So this is how the tangent graph will look like when A is negative. X and Y will have a vertical asymptote on the left and the other one on the right. Okay, and the graph. That's when A is negative. So as you see, this graph is kind of different than what we've seen before with the sine and cosine. First, we don't have an amplitude like what we had with the sine and cosine, right? And the other thing is the period is 1 pi. So you see how it's from negative pi over 2 to pi over 2. So the period is 1 pi. The tangent graph will repeat itself after 1 pi. While with the sine and cosine, the period used to be 2 pi. So it's important to keep in mind that period is pi over b, and it will be 1 in this case, 1 pi. Okay, next let's look at graphs for cotangent. And with the cotangent, again, the function will be y equals c plus a cotangent, this time, bx minus t. Okay? So with the cotangent, you either, again, look at the unit circle, but this time you're going to divide the x value by the y value, right? Or you say it's the reciprocal for tangent function. So here is when a is positive. You will notice with the cotangent that it will extend 2 steps to one side of the origin or the 0. So here is when if a is positive, cotangent, when you take values for x, like how we did with the tangent, you will see that the y-axis is the vertical asymptote. Okay? So, y is the vertical asymptote. So the cotangent will never touch it. And here we have one step, and another step here where, so for the cotangent, the values will be from 0 to 1 pi, 0 to pi, then it will start repeating itself. So here we have the other vertical asymptote, and you will have one step in the middle. Okay, taking all values for x and finding the values for y, which is the cotangent. Again, you either say it's x divided by y or cosine divided by sine. So whenever cosine is 0, the cotangent is 0. And because we're dividing cosine by sine, right? If sine is 0 in this case, we will have an undefined value. The graph will be, let's use a different one here to distinguish it from the vertical asymptote. And it should be like this. Okay. That's a graph of a cotangent function. When a is negative, we'll see how it will look like. There's x and y. Okay. Again, same thing. We have y. The y-axis is the vertical asymptote for cotangent. Here's we have a step in the middle, and here's the other vertical asymptote at the end of one period. Okay. The graph will be, this is for a is negative, so we'll write that. This is if a is negative, Then we want to say about the cotangent graph. As you notice, we have y-axis. The y-axis is the vertical asymptote. Sorry. Is asymptote. And it extends 2 steps either way. You see how? And again, we don't have an amplitude for the cotangent graph, just like the tangent. And the period, again, it's half of the period for a sine or cosine. So if the period for a sine or cosine is 2 pi, the tangent cotangent period will be 1 pi. Okay, so these have the graphs for tangent cotangent with positive or negative a. Now let's look at some examples when we see these graphs a bit shifted, either vertically or horizontally. Here we want to graph a1 period. Okay, let's look at the first example. Y equals 2 plus 3 tangent of x minus pi over 2. Okay, first let's see what we need to graph. So we see that the amplitude here is 3. The absolute value of 3, which is the same as 3. Period will be, let's see. So it's pi over b, right? Not we used to have it 2 pi over b. This time it's with tangent cotangent, it's pi over b. b is 1 this case, so this will be pi over 1, and that is pi. Next we have the step. We'll divide pi by 4. Oh, not 4, that's my bad. It will be by 2, right? Because in one period we have 2 steps, we said, of tangent and cotangent. So the step is the period divided by 2. Shift, vertical shift. Is 2 units up, and phase shift pi over 2 to the right. Okay. To graph it, we have x and y. And I know the graph will be shifted up and to the right, so give myself some room here. Okay. So the x values will be 0. Then we have pi over 2, that's one step. But remember, we have a vertical shift, so the x-axis will be shifted 2 units up. That will take me up here and say 1, 2. And there's a pi over 2 shift to the right. So here's my new or shifted y-axis. So this is the typical origin. It will be shifted to here, right? And remember, tangent go one step to the left, one step to the right. So it will go, and the period is pi. So in this case, we'll have the y-axis as a vertical asymptote. Let's do the asymptote for the right. Okay, and then to pi, to go to pi here, this is pi. Okay, now you can graph. And it's positive. A is positive, so it will and here is my graph. Okay. Next, let's look at another example. We will do a cotangent function this time. So number 2, we'll do y equals -1 plus 2 cotangent to x. Okay. Again, we have a period of 2, no, amplitude of 2. We don't actually label a period on the tangent cotangent function. Amplitude is 2, period pi over 2 because b is 2 this time, and then we have step. Step is period divided by 2. There will be pi over 4. Remember, for tangent cotangent, period is the step is the period divided by 2. Vertical shift, 1 unit down. And phase shift, no phase shift. I'll say none. Okay. Let's graph this function. So it will be shifted down 1 unit. We don't have a horizontal shift. So we just want to shift it x-axis. Okay. There's the x and the y, and this is -1. Okay. Remember cotangent, we said when we don't have horizontal shift, the y-axis is one of its vertical asymptotes. Okay, it will go one step, and then here, then second step, and the end of the period is the other vertical asymptote. And this period is pi over 2, so this is pi over 2. This is pi over 4. That's a one step. Okay, that's all what I need. Next, I can graph the cotangent, and since it's the A is positive, so it will look like this. You know what? This is the shifted over pi over 4. So here is my cotangent graph for this function. Okay, let's look at one example. This time, that's example 3. We'll do y equals negative 3 tangent 3x plus pi over 4. Okay, so this time we have horizontal shift, but we don't have vertical shift. And we'll say the amplitude is absolute value of negative 3, and that is a 3, period. Pi divided by 3. Step, pi, it's the period divided by 2, so that will be pi over 6, right? It's like pi over 3 divided by 2. Vertical shift, we don't have vertical shift, we'll say none. And phase shift, as you see, it's pi over 4 to, it's positive, so it will be to the left. Okay, let's graph. Okay, so here's x and y. We don't have vertical shift, so we will work around the x-axis, but the y-axis will be shifted this time, pi over 4 to the left. Okay, and since we have a step of pi over 6, so it will be shifted all the way here. So in yeah, this will be a negative, right? It's this one is shifted, so this will be negative 5 pi over 12. This is end of the beginning period. So this will be the first vertical asymptote. Okay. Second one will be here, negative pi over 12. That's my other vertical asymptote. That's a 1 period. Okay, we need one step here in the middle, and this will be negative 3 pi over 12. And as you see, I just wrote it like this. It's yep, that's it. Okay, here's the 1 period. Here are the 2 vertical asymptotes. It's a negative amplitude. There's a negative sign, so the graph will the negative tangent function, and so it will look like this. Okay, remember the negative, when we had a is negative for tangent, the graph look like. Okay, there is the graph for this function. And that was the last example that we have for graphing tangent and cotangent. Take care.